So, very good afternoon. Am I audible to you all? Just please write yes on our chat box. Okay, fine. Thank you. Now let us start with the machine learning, uh, machine learning decision tree. So, this is a part of our supervised classifier, and let us start with the decision tree. Now, this is our next topic, and in a supervised classifier, previously we have done the learning learning a class. Then we have done learning multiple classes, and third topic we have done k nearest neighbor classifier. And there is a fourth topic is there in a supervised classifier, and there is a, decision tree. And we also have a fifth topic in a supervised classifier, which is known as a random forest. So that one is the last. That one will be the last topic under supervised classifier, and the decision tree is the second last. And yes, definitely, it's a supervised classifier is there. And now let us begin with the uh, decision tree. Yes, decision tree is a hierarchical model, and definitely it's a supervised learner, and in which the local region is identified in a sequence of recursive splits in a smaller number of the steps. And here you can see that in this figure. And there is a tree which further splits into the further parts. And here you can see that the one is there, then the one is there, and again this is split into the two parts, and again this is further splitted, and this is a uh, again and again it's splitting into the up till the end. And a decision tree, there is an important line in a decision tree. Decision trees are composed of internal decisions, nodes, and terminal leaves. Now, only in a decision tree, you have to remember that first of all, it's a supervised classifier, and second, there are two terms which are associated with the decision tree. Those terms are internal decision, nodes, and or you can simply name it as a decision nodes and the terminal leaf. So these two points which are more relevant to the decision tree. And here, yes, we have already done this line, and here we have given the example uh, for the decision tree. For the decision tree, yes, before we go towards this example, we just check it out this tree. Yes, and you have to check it out the third example. Sorry, third line. There is a oval nodes are there which represents the decision tree, and these are the oval nodes are there which representing the decision nodes, and the rectangle nodes are there which are representing the leaf nodes. And yes, you have to remember that the leaf the decision nodes where we have to do the some programming part, or where we can take the decision, and the rectangle nodes which represents the leaf nodes. This is the actual outcome of this expression, and the expression is actually represented by the decision nodes. So hopefully now you are clear with these terms. That is the terminal leaves, or you can say that there is a leaf nodes and the decision nodes. There are two nodes are there. There is the first one is a decision node, and another one is a leaf node. And this one is referred to as a uh, decision nodes, and these are rectangular, are represented as a or known as a leaf nodes. So these two nodes you have to remember it while performing the decision tree supervised classifier. And yes, in this univariate decision nodes split along one axis and the successive plates are orthogonal to each other. And now this line is actually belongs to the this figure. And here you can see that there is a randomly there are two class categories that exist within a space, and this one is a space in actual. Here you can see that this is a space, and in which there are two classes are existing, and the one is circle, and the another one is a rectangular. So please don't correlate these circle and rectangle with these three. So just these circles and the rectangles are specifying the different classes, are specifying the different different classes. And here you can see that there are a lot of circles are there, and some rectangles are there, and the rectangles are known as C2, or we have labeled as a class 2, and the circles are labeled as a class 1. And here we have just divided according to this programming part. We have divided the entire space, and in this case we have divided into the four parts. That is simply uh, and here we can say it as this one. This is a y-axis, which is represented by the x2, and this is a x-axis, which is represented by the x1. And this w is a this w is basically defining the range. There is a w10 is there, and there is a w kind of you can say it is a w15 is there, and this one is ended at w20. And on the other end, where yes, definitely it is W20 is there, and it is increasing until the W40. So this is just a not a scaled form, but yes, some example is there. Now here first we have to apply a program on a x-axis. And when we have applied the program on x-axis, where the when the x is we have just mentioned that the x1 is greater than w10. So it means that we are talking about the x-axis. So the x-axis is greater than w10, then we can put into this category. Otherwise we can put into the another category. Okay. Here maybe you all are clear with this term. This x1, if your x is if it is no, here you can see that if it is yes, if it is greater than this, then we have put it over here. Then we have applied the another case. And if it is not, if the x1 is not greater than w10, then we can easily say it as a this side is basically belongs to the c1. So that's why we have just put it here c1 and x2. And when we have applied the another operation, when if the yes is there, if the w10, if x is greater than w10, so it means it is talking about this boundary. It is talking about this boundary, and in this boundary, there are circles are there as well as some rectangles are there. So they have applied the another expression, and which is specifying that if the x2 is greater than w20, and here we can see that they are talking about this region basically. And here I'm just mark it as a with the hidden lines, and here we can simply say it as a if in order to detect these rectangles we have to apply the two expressions. First, the your x1 must be greater than w10, and your x2 is must be greater than w20. So at the end you will able to detect this type of a class. So if you are clear with this term, then it is better. If you are not, then you no need to worry about it. And we will today we will do the multiple examples for the decision tree. So if it is you have clear about that, then it is okay. If not, no no worries are there. So yes. Yes, leaf node, yes, definitely. It is talking about these rectangular boxes. Yes, given an input at each node, a test is applied. Yes, this one is a test which is applied at each node, and one of the branches is taking depending on the outcome. So what will be the outcome? These are the your outcomes. It is a class one, and this is a class two. These rectangular basically representing the outcomes, and this process starts at a root. Which one is a root? This one is a root. The process starts at a root and is repeated recursively until a leaf node. And leaf node is there. There is a rectangle boxes are there. It will continue to splitting into the further until it will not detect this rectangle box. At which point the value written in the leaf constitute the output, and there is a value which is written in a leaf box, and this one is a rectangular box is there, and there is a square is in this rectangle box, and we can say it as this one is a output, and here the circle is there, that is a and this is just a brief discussion about the leaf node. So next we will do the uh, example for decision tree. Then it will explain you a little bit better. Okay, and let us start with this. Yes, here there is a space is there. You can just please hold for a second. Yes, on this slide. Yes, let us start with this point. And yes, okay. In a first case, we have divided a space in two parts, and here there is a R1 is there and R2 is there. There is a region 1 and region 2. How we can divide into this part? We can just there is some LOCs. Just there is a term LOC which is actually representing on a y-axis. This one is on a y-axis. There is a LOC is there. So LOC is there, and if it is less than 15, so there is a you can assume it as a there is a 15. If it is less than 15, then we can say it as a this is a region 1. This is a yes, and this is for no. And if it is a yes, then if it is less than 15, then we can say it as a region 1. Otherwise, we can say it as a region 2. So this is not the end of this of our decision tree, but we have to further split into the other parts. And here we have divided this part. We have just put it here because there are multiple class categories existing, and you can easily see it here. There is a one class green is there and the red is there, and both are existing in a region 1 as well as in a region 2. So we have to apply the another part, and here we have just written there, and this one is a 3. Yes, uh, yeah, the 3 is there. Yeah, 3 is there, and we have already done this part. If it is yes or no, and LOC is less than 15, and if it is a no, then means if it is in region 2, if it is in region 2, then and if it is like this one is a there is a y-axis is there, and sorry, x-axis is there in which the time is representing, And if is the time is less than 3, then we can say it as a, it means this area. It is talking about this area. So because this is less than 3 and this area is greater than 3. So it means if your expression is the time is less than 3, and then you can simply put it into the region 2, 1. Otherwise, you can put it into the region 2. So this is actually for the subset of the region 2, that is a 2, 1 and 2, 2. This one here you can easily visualize. And then uh, again, there is a third case is there, and we are talking about the region 1. In order to split the region into okay, how we can, in this case they have just divided the region. They have put it here. Here you can see that the region is divided into the two parts, and in order to divide this part, then you can simply use the, there is a minus 15. Okay. Oh, okay, this is actually representing the minus 15. So there may be a reference line. I think there is a reference line is there, and above this reference line it is representing in positive, and below this reference point it is representing the negative. So is the 15 is there? There is a reference point is there. Here you can see that. Here the 15, if it is a less than, if it is a less than 15, then we can say it as a region 1, 1. There is a region 1, 1, and if it is a greater than or not less than minus 15, then we can say it as a region 1, 2. So this is a concept. And yes, in order to perform the further, you can do it, or you can split this region into the further part also with your expressions, or we can say it as a with the help of the decision nodes. So now there may be a question, and question for you all. Then means in this figure, in this decision tree, how many nodes are there? How many decision nodes are there, and how many leaf nodes are there? So according to me, and according to all of us, there is a first question is how many decision nodes are there? Yes, first we have to check it out, the how many decision nodes are there. Here there is a one node is there is a second node is there, and a third node is there. So we can say it as a we have a three decision nodes. And the next question is how many leaf nodes are there? So we can simply say it as a there are one leaf node is there, second leaf node is there, third and fourth. So we can say it as a fourth leaf node is there. So this is the entire concept of a decision tree. And yes, in a decision tree, there is a problem of overfitting, and here you can say it as a yes. In a previous example, there is a problem. Yes, in a decision tree, and we can easily visualize in this region. And here you can see it as in a region 1, 1. Yes, the greens are existing as well as the reds are existing, and how we can put the both reds and green in a one class category. So there is again question mark, how we can get the accurate results with the help of a decision tree. So in a decision tree, there is a problem, and there is a lack of the additive structure. And here you can see that this one is not a decision tree. This one is not a decision tree. But yes, this is a concept of a decision tree, and in which we are just select the space and divide into the some further parts. And we are dividing, first we have divided the x, then we have divided, if I have to put it, and then I can put it over there. Yeah, in a first case, how we can just initiate this entire uh, tree. And here you can see that there is a 0.7. 0.7 is there. Now there may be a question for you, all of you. you have to design the decision tree for this space. So the dotted lines is actually given to you all. Then how you can design it? Then it is very simple. If the concept of a decision tree is clear to you, you can easily do it. And means if you assume it as a this one is your x, this one is your x1, and this one is your x2 is there. And then if you from where I will do this. Okay, we will do it from this part. If x1 is greater than 0.7, if x1 is 0.7, then uh, this one is a yes, and this one for the no. Yes, if it is a yes, we can say it as a this one is a region uh, 1, and we can say it as a this one is a region 2. If it is a less, uh, yeah, if x1 is greater than, then yes, then we can define it as a region 1, and this one is a region 2 is there. And then we have applied the, in region 1 case here, we have applied another operation. If the, in this case, if the, here we can just write it as a, if the x, there is another operation, there is a, if x1 is, sorry, not x1, if the x2 is, here we can just check it out. Which line is there? It is approximate to 0.1. It's little bit exist in between the 1 and 2. So we can simply write it as a 0.15. Okay, if it is greater than 0.15, if it is greater than 0.15, then yeah, we can say it as a, if it is yes, and this one for no. If it is greater than this, we can say it as a region uh, 1 1, and this one is a 1 1, and otherwise we can say it as a region 1 2. So region 1 2, and similar we can split into the further parts, and with the multiple decision nodes and uh, till the leaf nodes. And this one is a R2 1, and this one is a R2 1. There is a 3 is there, not 3 is there. There is a 2 1, and this one is a 2 2 basically. Yes, because the R2 is divided into the two parts. There is a 2 1 and 2 2, and again, this one is a R again 2 2, and it is further split it into the further parts. You can just name it as a any other, not as a like this. That is a R1 1 R2 2. If you want to use it as a A B C D E F, you can use it as a alphanumeric, or you can also use this numeric number alphabets as well as the numeric. So, and here you can see that in F case, in a F case, the green as well as the red circles are both are existing. So that is problem is actually called it as the overfitting problem. So here we can, if the case is if such kind of a case is given to us, then we can easily do it with the regression. And here you can see that there is a linear line is there, and which easily separate the two classes. So we can implement the other case as we can implement the other classifier as compared to the decision tree. So in such type of a cases, the decision tree results are not much accurate, and here you can see that there are in this region there is a D region. There are red and some reds are existing along with the green. So we can't get the accurate results. But yes, if we will apply some kind of another classifier which exactly separate the red and green, then we can say it as a the another one is a more beneficial as compared to the decision tree. And the purpose of this slide just to explain you that where the decision tree is actually lacking, and there is a hopefully you all are able to understand what is the problem of the overfeeding and what is the main disadvantage of a decision tree. And another we have this is another example. There is a loan approval via decision tree, and now this one is maybe a beneficial uh, main application of a decision tree, and we can use it in a loan approval. And if there is a age is there, that is it is simply divided into three parts. That is a young from 18 to 30. You can assume it as a. Then there is a 30 to 60. You can assume it as a 32, and this is a 60, and this is a more than 60. And yes, if has a job, on house, and credit rating. So these most important parameters on which loan is given to you. And the third one is a, and this third one is a, uh, oh, 1 second. Yeah, and this one is the last one is there. There is a class is there, which is actually representing the uh, approval of your loan or not. And this one is yes for approval and no, no for not approved. So if you don't have any job and if you don't have on house and your credit rating is either fair or good, it doesn't matter because you will not get the loan. So you will not get the loan. So definitely there is a okay. If you don't have a on house, there is no problem. If you have a job, but as well as you have a good credit rating, then you will allow to get a loan. And if you have a job and you have a house and you have a credit rating little bit fair, not a good, then you can also get the loan. And there are several cases are there. And uh, how we can train computer to decide input by inputting the job status as and home status and credit rating. Then it will automatically will tell you that are you able to get the loan or not. So this is a kind of a example which can be easily accomplished through the decision tree. So, and let us start with the step by step. Yes, first you have to do the learn a classification model from the existing data. And what kind of a data? This data is there. So this is a data which is actually prepared by the banking or banking companies, and at what case you will get a loan or not. And yes, this is a for the classification is there. There is a yes for approved and a no for the not approved. And now you have a case. You have a age is young, and you have y- no, you don't have any job, and you don't have any home or house. Then and your credit rating is good. Then will you get the loan or not? So there is a question mark. So machine can solve it. How it can solve it, and with the help of a decision tree. Yeah. So this is a little bit point scoring, and you can ignore it for a time. Yes. Your age. First, it will look it into your age. Are you young, middle, or old? Yes. You are a young. Do you have a job? Yes. If you have a job, then you will get the there because you are fulfilling the two requirements. There is a young and you have a job. Then yes, you will get the loan. And if you are young but you don't have a job, then you will not get a loan. And in another case, if you have a middle age, you have a house, and then you will get a loan. And if you don't have a house, then you will not get a loan. And in the third case, There is a, if you are a old, if you are old person, then, and you have a credit rating, good credit rating, then you will get a loan. If you have excellent, then definitely you will get a loan. But if you have a fair credit rating, then you will not get a loan. So there is a simply a decision tree. We can use this decision tree to get this output, and in this case, you will not get the, loan, and this fall under, yes, your age is young, and this is existing over there. Do you have job? No, you don't have any job. Okay, not this one. Yeah, you don't have any, no, then you will not get the loan. Hopefully, you are able to understand this example. And yeah, again, there is another example is there, but I will not give you the more examples. Hopefully you will able to understand that this decision tree. And then now, what you have to do, you can convert the decision tree into the set of rules very easily. And how you can do it? Yes, it's a very definite, it's a very easy process. Refund, if your refund is yes, uh, then ultimately your outcome will be no. And here you can simply convert it. Here you can check it out. There is a third operation is there. There is a, there, yeah. Here you can check it out. Yellow box, and there is a rules for each decision node as well as for the each leaf node. So a decision tree can be converted into the set of rules, and each path from the root to a leaf is a rule. Hopefully you are clear with this line. And means a decision tree can be converted into the set of rules, and each path from the root to a leaf means if there is any path from the root, and this one is your actually a root. Oh, okay. This one is a root, and there is a path, and this is a path which is actually going on, and this is actually a rule, and we can easily do it with the help of a classification rules. So just we have to put it here. What is a taxable income, and is it a more less than 80,000 or a greater than 80,000? And this is the algorithm. And hopefully, you can also do it with the help of a C language, and you can do it with any other language. And means you doesn't require any kind of Python, or you need some expertise in a specific language. And definitely you can also do it with the Excel sheet. Yes, Microsoft Excel. So it is very easy. You no need to be a programmer uh, to learn the machine learning. So it's a very easy. You can do it with the help of. But yes, the basic knowledge is definitely required. How it is working. Then you can decide your own rules, and how you will implement it. That depends upon you. Either you can use any programming language, or you can also use the some modeling type of. And yes, the I already explained you this part. There is a overfitting problem is there in the decision tree. Okay, who is coming now? Okay, we will take only last. Okay, okay. There is a problem in our decision tree, which is known as a overfitting problem, and in which there are more than one classes are exist within a, oh, sorry, in which more than one training sample exist within a same class category. So this is our actually your classes. This one is a A class, and this one is your B class. C class is there, D class is there, E class is there, and the F class is there. So there are multiple classes which are existing in case of a B, in B case, as well as in a D and F. So you will get the maximum errors in these three classes, and you will get the accurate results in the case of A class, C class, and the E class. How we can do the how we can overcome the overfitting problem? Yes, we can do it with the two approaches. There is pruning, there is a pre-pruning and a post-pruning. And in this case, you have to halt the tree construction earlier. So basically, if you will use this method, means because it is basically telling you that you have to make a shortest tree. No need to just elaborate in such kind. You have to just end it over one or two functions, or not goes to up to four or five layers. So that is very difficult for us because we don't know what may happen subsequently. Because at the end we will not get into the if I am taking the example of this loan, it is okay. If I will take the example of this, then we can't get into the end result. So here you can see that we have just processed we have done a pre-pruning, and in which we have just get up to this point. There is a region 1, 1 and 1, 2. And still here you can see that there are a lot of errors are there, and means there are multiple classes are existing within a same class. And we further need to subset it basically in this case. So, if we will do the or avoid the overfitting problem with this one, then definitely we will get the some uh, poor results. And postponing, which removes the branches and subtrees from the fully grown tree. And yeah, you can do it with this method. But yes, again, I tell you, okay, this is basically a statistical method to estimate the errors, and which actually there is another equation is there which estimates the error at each node, and then you have to perform that step again. So that is a little bit complicated for us, and you have to just check it out. What are the actually examples of where you can use the decision tree, and there are very limited examples are there, and this is a here we can, yeah, in this case in a loan data we can easily use it the decision tree. But yes, if it is an example of some kind of time is there and the allos is there, and yes, here it will not work so well. So you just have to, and this one is a case of, again, this is a case of same, so it will not work there properly. So this is an algorithm. You no need to worry about it, and definitely I'm sure that you all can do it with the help of any language, or you can just set the simple rules. You can just set the simple rules, and you will get the uh, your results. And yes, if there is any question, then you can please write it on our chat box. And now we have a time to handle your queries. Yes, please write it on our chat box if you have any question. Uh, Otherwise, you can also mark your attendance at these links, and these links are active for next 10 minutes. And if those who have any question, then you can please ask. Yes, once you have marked your attendance, then please let me know. Okay, Dhananjay, just wait for a second. Okay, please don't leave the session once you have marked your attendance.